just one interval from 0 to 6. And state the intervals on which the graph is concave down. It's concave down from -8 to -5, from -5 to 0, and from 6 to 8. And the last thing, for what values of x does the graph of f have a point of inflection, also known as inflection points? So remember, points of inflection come from when the graph at a specific point changes concavity. So the possible points of inflection, or where the second derivative is 0 or undefined, would be -5, 0, and 6. But we can see at -5, the second derivative does change sign. It doesn't switch concavity, so negative is not a point of inflection. But at 0, it does from concave down, concave up. The second derivative switches from negative to positive, so this would be a point of inflection. Just abbreviate it here. Also at 6, the second derivative changes positive to negative, so switching from concave up to concave down, making that another point of inflection. So now we can answer part C. For what values of x does the graph of f have a point of inflection? So we can say f has points of inflection at x equals 0 and x equals 6. And justification would be since at double prime of x changes sign. Again, a little more specific. If you just say that, that's a little too vague. I'm going to specify at x equals 0 and x equals 6. And that concludes the notes on the topics of analyzing the graph of the velocity function and analyzing the graph of the second derivative.